Hello, and welcome to 5 Minute Math. Today we are looking at the third grade concept of composite area of a rectangle. This is standard 3.6D in the great state of Texas, and we are using item number 3 of the 2023 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. All right, so we've got this shaded figure here on the grid, and we need to find the area of the ceiling in square feet, and it's that shaded area that represents the ceiling. Okay, so there's a few different ways we could solve this. All right, so the shaded area represents the ceiling. And what is the area of the ceiling? So that shaded area. Well, one thing that we start looking at in third grade is what is area? So the area is literally the number of squares, real or imaginary. In this case, we can actually count the squares, but the number of squares that we would find on the inside of a two-dimensional shape. Okay, and if it's a rectangle or a square, right, we can represent it with this formula. Area equals the length times the width. Or sometimes we'll call it the base times the height. It's just one side times the other side, but sometimes we call it the base and the height. Sometimes we call it the length and the width. Let me show you what I'm talking about. We don't have a rectangle here. But if I were to take a black line right here and chop it just like this. Okay, so now I can make a rectangle and a square. Okay, so what do I know about this rectangle and a square? Let me start with this rectangle, right? This rectangle has a length of 1, 2, 3, 4, because there's 4 squares down, and a width of 1, 2, 3. Okay, so if I were to find the area of that rectangle, I would say, well, that would be 4 times 3. If I wanted to do the base is always the bottom. That would be 3 times 4. Either way, it's going to be 12. And I know it's 12 because if I wanted to, I could literally just put the numbers in there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Eventually, you'll start seeing in fourth grade and fifth grade area problems without the squares on the inside. So you have to know length times width. Okay, so now I could take a look at this other square right here. And it's just a square, and so the area of a square is usually, they just call it side times the side. You can also say length times width, but they're the same thing, right? That's 2, and that's 2. So that's going to be 2 times 2, no matter how you look at it. That's going to be 4, because I've got 1, 2, 3, 4. So if I wanted to find the area of this big old ceiling, I would need to add those two together. I would need to say I've got my 12 plus my 4. That's going to make 16. So we're looking at D, 16 is our answer, but watch this. What if I cut it a different way? What if I wanted to make it 2 rectangles? Could have done it like this. Would we get the same thing? Well, let's look at this top one, right? So there's my length, right? And there's my width. Okay, so I'm going to have my length is 2, my width is 3. Okay, so the area of the top one is going to be length times width equals 2 times 3. That's going to equal 6. 1, 2, 3, 4, 5, 6. What about this bottom one? Okay, we could do length times width, base times height. That's 2. This is bigger. 1, 2, 3, 4, 5. So area equals length times width. That's 2 times 5. That's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, this is a composite shape. That means it's 2 rectangles stacked next to each other. There's no overlapping. There's no gaps. And so if I wanted to figure out what the total is, what could I do? Well, I could also add my two totals. 10 plus 6. So you notice I cut it a different way. Still got the same answer. Either way you look at it, the area of this ceiling, this composite shape, is going to be D, 16 square feet.